All right. Hey, my name is Alexei. I'm the co-founder of Interlay. I've been doing research on bridges for the last 5-6 years. So I started my PhD at Imperial College in London, where we really work with quite a few people that build bridges, and we try to come up with the foundations of why bridges break, why it's difficult to build them, and how we actually can achieve trustless bridges. And the talk today will walk you through a deep dive into why a bridge is important. Why is it really so difficult to build them? And then some sneak peeks on, what's coming. Now, I think I don't need to talk a lot about why we need bridges. It's pretty obvious there's not going to be one chain to rule them all. And even now with L2's rollups on Ethereum coming up, we need to be able to communicate between different chains. But there's a problem, right? Less than 10% of the bridge volume today, and I don't remember the numbers, but it's in the billions essentially, is decentralized. And there's a few exceptions with Polkadot, having some bridges within their ecosystem, but that requires it to be a Polkadot parachain. Cosmos, IBC, right? You kind of can bridge between these chains, and that's somewhat decentralized. Our Bitcoin bridge works that way, and then some L2 bridges. But that's a quite limited amount, and we still see the centralized bridges being massively dominant in the market, and then they just keep breaking. So one important thing to understand with bridges is that when you're bridging, you're actually depositing into a network or a platform, right? Your assets can only exist on the chain they were initially minted on, just from computer science perspective. So if I just put on my computer science hat and I look at how bridges work, there is not much difference between depositing into Binance, into something like Cash App, or into an L2 or in another network. The process is the same. I deposit into a wallet, into an account on the original chain. Let's say I deposit ETH into an Ethereum, and someone controls that wallet. And the question is, well, who is this person or entity? So the goal of bridging is, well, I want to deposit ETH into an app chain, and I use app chain here as the general term for L2s, application chains, whatever else you want to call it. Use ETH there as if it were a native asset. I don't want to worry, whether I can use ETH with a swap on zkSync or something like a lending protocol on Arbitrum. It should just work out of the box. Just like when you deposit your ETH into Binance, you don't have to figure out, oh, is it compatible with trading, but maybe it's not compatible with some of the other products. And then I want to get my ETH back, right? I always want to be able to withdraw my assets back to Ethereum main chain. And the user experience ideally should be as good as depositing into a centralized exchange. One click, I'm there. I don't have to worry about, figuring out which bridge I should use, and it should be secure. Now, trust models, I'll briefly skip over that, but it's important to remember. Single chain means I only trust one network. I have a wallet. I hope that that wallet works, and I can verify looking at the code. If I'm going multi-chain, there is now 2 of these networks. So I need to trust that chain 1 is secure and chain 2 is secure. If one of these things breaks, well, then I shouldn't be using them, and I will not be bridging to a layer 2 or another chain if I don't trust it. But then I have now 2 wallets potentially, or 1 wallet with different accounts and different chains that I need to manage, and there needs to be a bridge. And that's the thing that usually will be the dangerous part. Just like think of crossing a chasm, you're crossing between 2 cliffs over very high place. That's the dangerous bit. So wrapping, you're all familiar, right? Point made, Ethereum only exists on the Ethereum chain. And to bridge it over, I need to create a representation. So wrapped ETH, and I know it's sometimes confusing because we have wrapped ETH as well on Ethereum directly, but essentially I need to create a representation of Ethereum on another network. So whatever this thing is called, let's call it XETH just for the time being, that tells me, okay, if I have this, then I can claim 1 Ether on the Ethereum chain. In computer science terms, this means that I'm obtaining a write lock on this coin on the Ethereum side. So this means that no updates can be made on Ethereum anymore on this asset. So this means nobody else should be able to move it around on the Ethereum chain while I'm using it, let's say, on an L2. But if I transfer this asset to somebody else on an L2, obviously, only that person should be able to get back the original Ether on the Ethereum main chain. Pretty simple. So why is it so difficult then? How come these bridges just keep falling apart? And this brings us back to probably one of the oldest problems of e-commerce or commerce, the fair exchange problem. And bear with me, I'll explain why this is relevant. So in the fair exchange problem, Alice has some coins, she wants an apple, Bob has an apple, he wants the money. Simple problem. Well, what do? there is a reason why marketplaces existed in, the medieval times, because obviously, Alice does not trust Bob, and she does not want Bob to rob her. So they would meet in a public place, and then they exchange goods. But what happens if you're on the internet? And the problem of fair exchange is that somebody has to make the first move. I have to give you the money before you send me the goods, or vice versa. And to ensure fairness in 100% of the cases, we need a trusted third party. And there's actually a formal proof for those of you who really like academic papers from 1999. Right? So we need a trusted third party to always exchange goods fairly. So how does this relate to bridging? Well, when I'm bridging, I'm wrapping assets. And wrapping is basically I swap my native ETH for the ETH on the other chain. And when I go back, what I'm actually doing is I'm swapping the wrapped ETH for the actual ETH on the Ethereum mainnet. And someone or something needs to do the locking and unlocking, right, of Ethereum on the main chain and like the wrapped asset on the target chain and vice versa. So something or someone. So, and that's the bridge problem, right? If Alice wants to bridge over to, let's say, Polkadot from Ethereum and mint some wrapped Ether there, well, she needs to make sure that she actually gets the wrapped asset. And Bob, who might be the final recipient of that wrapped Ether, well, he really needs to be sure that, this is actually backed by ETH. And the goal is to make sure that these things are always atomic. You should never be able to get the wrapped asset without locking Ether first, and vice versa. You should never be able to claim Ether without actually burning or locking the wrapped asset. And, well, the way to do this is, well, it's actually picking a suitable custodian. So somehow we need to make sure that the ETH is locked and unlocked in time. Simplest way possible, use a centralized party. Send it to Binance and withdraw to the other chain. Trust that Binance will do the right thing. Well, we know that some bridges have been operating in this model. In fact, I would argue that 90% of bridges today that connect different chains operate either in the centralized entity model or in the committee federation model, where you say, well, it's not one person, but there's a multi-sig, a federation of trusted entities. The next step to kind of, move along this like spectrum of trustlessness is to say, well, let's not use a multi-sig of maybe 10 or 20 people that are always the same. They might get corrupted over time. People tend to get corrupted over time, right? So, or they might at least. So let's use a consensus network of a third-party system where, anybody can join and leave. There's some consensus. That thing is hopefully decentralized, and we'll trust that. So that's where we're moving into the space of like Axelar, for example, follows this model. And I think, more and more bridges are trying to kind of go in that direction. So the idea is now, okay, it's not a fixed multi-sig, but at least it's a multi-sig or threshold sig, but it's changing. But then the optimal case, is I only trust the source chain and the target chain, and I trust that the consensus of these two things, because, well, I trust these two chains anyway, otherwise I would not be bridging. And how most centralized bridges work, right? You lock ETH, you deposit ETH, and this entity, right, this custodian here, and that can be one person, a group of people, a third-party network, they will attest that, hey, I actually got the Ethereum, now please unlock, and they tell the smart contract or another issue, like a centralized party on the other side, to give you the wrapped Ether. And if you want to go back, well, you have to return it, and you request again that this party gives you back your tokens on the Ethereum side that you previously locked. But what happens if that party misbehaves? Nothing. You have no protection. You can try to sue them, right? But that we're trying not to rely on the legal framework here when we're bridging in the DeFi world. And well, the question and the argument here is DeFi really DeFi if your bridge is CeFi, right? If you're bridging from Bitcoin to Ethereum or from Ethereum to another system, are you really using DeFi if your counter, like the middleman is a centralized third party? Arguably, no, right? And just these hacks here, I mean, some of this money was returned, but that's over $1 billion lost. And these are just cases where, private keys were compromised or access control permissions were broken. So that's just from, multi-sig bridges mismanaging their keys. And now recently, multi-chain is another quite sad example, unfortunately. And if you're affected, I really hope that you manage to recover the funds. We don't know what's going to happen, but again, team lost access. So how is that possible that in a MPC-based system, team can lose access to all the keys? That should not be possible, right? So the question is, how do we build a decentralized bridge? And as mentioned, the best case is that we just trust the two chains that we're connecting, right? And this way we can ideally inherit the security and decentralization of the connected networks. So example, Ethereum verifies the state of Polkadot, right? Or Avalanche or Arbitrum, right? And L2 bridges are a special case because some of them actually already do that. But ideally, Ethereum is aware of what's going on the other side, and the other side, let's say Polkadot, knows what's going on Ethereum. And the only thing that you need in this case, right, is one party to just relay the data. So you need a relayer, someone that will make sure that the chains are aware of each other, and this can be anyone. This could be yourself, right? So if I'm using the bridge, I might just run the relayer to make sure that, it's actually working. And this thing is called a light client bridge because Ethereum has a light client for Polkadot, and it's the same thing that you have on your phone when you use a wallet, because obviously your phone does not download the gigabytes of data, but it just stores a few metadata, it stores the block hashes, and then that allows you to verify that certain transactions have happened. Now, fun fact, this has actually been known since 2014 and even before that, right? The famous sidechains paper by Adam Back and all coming from Bitcoin, right, actually described it back then, right? Use SPV proofs, which is like light client proofs, and just do that. So how come we don't have this yet? And we'll get to that at the end. So how light client bridges work is, well, instead of locking ETH with a custodian, you put it in a smart contract that is controlled by the consensus of that network on Ethereum. You send the proof, so you or somebody else relays that proof to the target chain, and that target chain contract unlocks X ETH to your wallet. Perfect. I don't trust anyone in this case. Maybe the relayer. If I want to go back, same principle. Lock in the smart contract, submit proof, unlock. Perfect. So actually, this is the way to securely bridge assets. What happens if the relayer misbehaves? Well, we don't care because we can just do it ourselves, right? And if you're a protocol that is building on bridges like this, your incentive is to run this relayer yourselves. It's not particularly expensive. You're just running the full nodes for both networks and sending the data, but this makes sure that there's always some correct data on these chains. Now, how do we verify cross-chain state? Again, like clients, right? So tracks block headers, verifies proof of work or proof of stake, verifies transactions. Security model, if it's in the main chain, right? So if a transaction actually got into the chain that has the most proof of work or proof of stake, then it must be valid because otherwise it would mean that somebody managed to attack Ethereum or Bitcoin or something else, and then the security model breaks anyway. So that's how it works. Now, I will skip over this because we're running out of time, but economic security is also something worth considering, right? So if we have two chains, green and gray here, and we're bridging assets between them, well, let's say the size of the green circle is a security budget. So what it costs to actually run an attack over a few hours on chain A, and chain B has a smaller security budget. So it's like a smaller cap network. And the assets that we're bridging are like, the green circle is like the amount of value that we've bridged over. That looks fine because, still secure, but what happens if the amount of assets that we bridged over in terms of value exceeds the security budget of the target chain? Then in theory, there could be an incentive to actively attack it to try to steal the assets. We haven't seen it in practice on Ethereum today, but there have been cases on Bitcoin, in fact, where chains were 51% attacked that were kind of connected to Bitcoin merge mining with it. So one way or the other in the future, if we don't pay attention, this actually might happen, and theoretically it will happen, right, at some point if it's possible. So it's always worth paying attention. Right, I'll skip over economic security bridges because we don't have time to talk about that, but for Bitcoin, you need to use collateral, right? So Bitcoin does not have smart contracts, so we need to come up with more creative ways to make these trustless bridges work for Bitcoin, and these things really do rely on economic security. So, outlook. Unfortunately, there will be chaos, right? So there's a dozen of centralized and hopefully soon decentralized bridges, and well, mainly centralized, honestly, and the result is that you have fragmentation of liquidity. As a new protocol, you have to choose, well, if you're not on Ethereum, which bridge do I use? Wormhole, Axelar, multi-chain, and I could go on, right? There's a very long list of bridges that I could use, but then the assets are not compatible. If I have Wormhole ETH and Axelar ETH, that's not the same asset. I cannot use them, so that fragments liquidity. And then the other thing is if you're not an EVM chain, well, bad luck, because most of these things currently only support EVM. So you end up, bridging and hopping through an EVM chain that you might be able to connect to. So, for example, on Polkadot, you bridge through Moonbeam. And that, again, creates even more fragmentation. And as a protocol or a sidechain, layer 1, layer 2, you have to choose, like, do I put all my eggs into one basket and trust only one bridge? And if it happens to be multi-chain and it breaks, well, bad luck. Or do I fragment my liquidity and hope that, well, if only one breaks, my damage will be limited, but then you make your network unusable for most people. The question is, well, I've been telling you about Likeline bridges. Where are they? Why don't we have them today? Well, the thing is, like, there is no one way to build Likeline bridge. These things are specific to the chains you're connecting. For Bitcoin proof of work, works. Built, it's possible. Litecoin's proof of work, right? The function that uses memory hard, so it's super expensive to verify. And I think Vitalik once posted it takes like, what, 50 Ethereum blocks to verify one Litecoin block. So that doesn't really work, does it? Ethereum proof of stake, yes, there are bridges in development, but again, we saw like this Altair debate, whether it's actually secure enough. And this is a quite new technology. It's not that easy to build. There's still some uncertainty. So yes, it kind of works, but we're not 100% sure if it will work with like billions of dollars bridge to that system. So you need additional security measures or changes to Ethereum. Solana, again, people are working on it, not there yet. So these things take a long time to build. There's a quite tough engineering challenges. And another pointer here, ZK does not solve this problem, right? So yes, zero knowledge proofs allow us to compress data, right? It makes it more efficient. But if you cannot do it without zero knowledge, it's not going to be much easier to do with zero knowledge. So yes, you might be able to find a circuit for Litecoin's proof of work to verify that, but it's going to be very difficult, right? It's going to be a tough engineering problem. You're going to spend a lot of time, and this is why basically we don't really have Litecoin bridges today. Exceptions, chains that are built to be interoperable like Polkadot or Cosmos, but they only really work between each other, right? Same consensus, and it's kind of built with Litelines, and even there, right, we're still in the early stages. But I do believe that there is good examples of things that already work. As far as I'm aware, Polkadot, Near, and Cosmos will likely have Ethereum Litecoin bridges by the end of the year, if we are to believe recent development. So fingers crossed that these examples will go live and actually prevail. And my bet is, having spent quite a few years like working on bridges, advising projects, doing deep dives into different designs, hopefully, but I'm pretty sure in 5 years' time, we'll have Litecoin bridges between all the big networks, and you will not have to trust centralized bridge providers. So we'll have one Litecoin bridge between Ethereum and Polkadot, between Ethereum and Avalanche, for example, and there will be no need to use a centralized bridge provider. And with that, thank you so much. Let me know if you have any questions.
Okay, time for questions, guys.
Otherwise, you can also just drop me a message on Twitter.
Thank you for the presentation. So we missed a little part. If we have some time, so maybe we can go through the slide that you skip.
Do we have time?
You are the last one.
All right. Well, then let's quickly talk about Bitcoin. So, reminder: bridging on Bitcoin is like bridging in really, really hard mode because Bitcoin has no smart contracts. So what do we do then? What we have to do is, well, we can trust WBTC, which is BitGo, or we try to emulate what a smart contract would be doing. So, and this is something that we've designed in 2018, and that's been actually live on our network for a while now. So what you do is you say, well, step one, we don't want to trust only one party. We allow anyone to become a bridge operator. So instead of BitGo, you have a network of people who can sign up to become a bridge operator. Now, these are the people who will get your Bitcoin. So just sending Bitcoin to random people is not going to make it better. It's actually probably worse. So how do we make sure that they don't misbehave? You use collateral. So the same mechanisms that make Bitcoin work in practice. Bridge operators lock collateral in different assets, and if they lose your Bitcoin, you liquidate them, right? And how it works is, in step 0, vaults register. Anyone in this room can go spin up a vault now, and you will have to lock up collateral in DOT, USDC, hopefully soon Ethereum on the network, but you can use any asset, right? Should be like a MakerDAO, voted on governance, risk parameter management properly, and so on. And then when the user deposits Bitcoin, you pick one or more vaults, you send the BTC, and the moment you send the Bitcoin, the collateral is locked. And as a user, you know that, well, if these guys lose my Bitcoin or they don't return it to me when I want to go back, I will get their collateral and I'll be, reimbursed and I'll not face financial damage. And in the good case, in 3A here, for example, right, if the vaults behave correctly and they send Bitcoin back to the user, they'll get their collateral back. If they don't, if they fail, right, go offline, they will not get their collateral. User is reimbursed. They can keep the Bitcoin, but I have money in different assets that can go and that I can use and go and buy actually Bitcoin on the secondary market. And we use cross-chain proofs in 2 steps, right? So when you mint as a user, you have to prove to the smart contract that you actually sent the Bitcoin, and the vaults have to, in step 3A, prove that they actually return BTC to the user, right? So you can't really lie to the system. It's not optimistic. It's not fraud proofs. It's you're guilty until you prove that you're innocent. And this way we can always ensure that, if something does go wrong, we can liquidate people, or you as a user, if you never sent the Bitcoin, you're not going to get any wrapped assets. So that's how you do it for Bitcoin. Challenge here is capital efficiency in scaling that, and this is where liquid staking, restaking, and like reusing collateral in like DeFi can actually make it work at scale. Yep, so that's how you do it for Bitcoin.